Okay, I'm going to move on to talking about how to graph the tangent and cotangent functions. So first thing, let's just remind ourselves, how does tangent relate to the values on the unit circle? Well, we know tangent is y over x, right? Or the sine over cosine. And this is important to think about because now we realize, well, tangent is really just slope. So I have a little demonstration here to kind of help us understand that a bit better. So as I move these points around the unit circle, right, this is a radius of 1, it's a unit circle, you're going to notice that whatever is sketched in blue is going to be the sine function, whatever's the cosine is going to be green, and then tangent, which we haven't even seen yet, is going to be in purple. Okay, so let's take a look here. So I'm going to drag C around. The slower I go, the better the lines are. We'll talk about in a minute why this happens and what's really happening. Just retrace it one more time so you guys can see it. Okay, so what's happening here? Well, again, here is our sine curve. We're familiar with that. We spent some time graphing that. Here's our cosine curve. Now, what's happening with tangent? I see in purple here it goes up, and it's somehow down here and goes up again, and then once again it's down here and goes up. So that looks kind of strange, and let's think about what's happening. Think about, I'm moving this C, which helps me form theta. Think about when my cosine is, let's go, cosine is 0. Okay, so cosine is 0, I'll go right before 0. Notice that my graph is going up to what's infinity. How about when my cosine is at -1? Well, at -1, my tangent graph is at pi. And then here, when cosine's 0 again, notice what's happening. All right, so let's take that and understand how this graph works. We're going to graph tangent from sine of x and cosine of x. So on this graph currently is sine of x and cosine of x already. Okay, and what we are going to do is we're going to graph tangent knowing that tangent is sine over cosine. Okay, so we're going to go with our main points here. So this is pi over 2, pi, 3 pi over 2, and 2 pi, if we weren't already aware. So at 0 here, okay, remember, what's x and y? Well, if we divided, we would have 0 over 1, which is 0. At this point here, they're both the same. And if I divide something by itself, it equals 1. Here, notice this time I'm going to have 1 divided by 0, but that's undefined. When we have undefined values, graphically, a lot of times we're going to have asymptotes. We could have a whole. In this case, it's an asymptote. Let's do the same thing here. Now, these are opposites of each other, but they are the same value. I know it's kind of hard to tell because we don't have the exact value, but that will be at -1. Here, I have 0 divided by 1, which is 0. And here, I have a negative number divided by that same negative number, which is +1. Here, I have -1 divided by 0, which is, once again, undefined. So I can go ahead and keep filling in the graph the same way. And you're going to notice this pattern that's happening. And I'm going to go ahead and plot my curve. Okay, so we got the graph of tangent of x just by looking at sine of x and cosine of x. What happens when I divide my sine value by my cosine value? And the key thing here is noticing that we have all kinds of asymptotes because we have undefined values anytime that we're dividing by 0. because cosine is 0 at 2 places on the unit circle, right? So if just by looking at this graph, if we were to find the following, first of all, our domain. Well, I'm thinking left to right on this graph. It's everything except every place where we have an asymptote. So how can we write that? Well, let's write 1. So it's all real numbers except x cannot equal, let's just write one of the asymptotes, so pi over 2 works. Except x cannot equal pi over 2 plus, now these intervals go by pi, so pi n. Okay, so that's the distance between the asymptotes. So, you know, if I had 1 for n, negative 1 for n, it would cover everywhere where I have an asymptote on here. Okay, our range, well, this one's a bit simpler. Our range is negative infinity to infinity, thinking bottom to top. The next thing is the amplitude. Well, remember we defined amplitude before as being half the distance of the range, but how would I take half of negative infinity to infinity? Well, we can't. Okay, so that doesn't exist. And the period, now here's something I want us to go back and look here. Remember, period means one complete cycle. And I see a cycle here, a cycle here, and a cycle here. So I'm going to use my highlighter on here and just really highlight for you what one period of this graph is. So this is one period of the graph, which goes from negative pi over 2 to pi over 2. So what's the distance of this period? Remember, period's always going to be positive. Well, it's pi. Oops. Okay. So one complete cycle is a distance of pi. Now, you'll notice here that this graph is really unique, especially compared to sine and cosine. In fact, tangent is the only graph that starts, its period starts at negative pi over 2. Because all the other ones start at 0. Think about sine, cosine, and we'll learn about the other ones as well. But tangent's the only one where it would start, with the exception of you know, having transformations or shifts to it. It's the only one that starts at someplace other than 0, which it starts at negative pi over 2. Okay, so we can do the same thing as we did for tangent for cotangent. So remember, cotangent is equal to cosine over sine, right? That's our quotient identities. So let's go ahead and do that. So let's figure out our cosine value. Let's start in the middle here. Let's go with blue this time. In the middle here, so we would have 1 divided by 0, which is undefined. So I'm going to put my asymptote here. Here I have the same number divided by itself, so that would be at 1. Here I have 0 divided by 1 is 0. I have a positive and negative value divided by itself, so that's going to be negative 1. And here is undefined again. So I think you guys can kind of catch on to what's happening here. I'm just going to go ahead and fill in the rest of this, as should you. So again, here's negative 1, 0, 1, undefined, negative 1, 0, 1. Last but not least, I'm going to fill in this curve. Okay, so if you're thinking that that looks really similar to the tangent graph, it does. In fact, this is the tangent curve with a negative, right? Because it's decreasing instead of increasing. It's negative, and it also has a shift. So yeah, you should see a similarity there. So let's identify the following. So once again, for cotangent, it is all real numbers, except x has some vertical asymptotes in there. X cannot equal 0 plus, that's one of my vertical asymptotes, pi n. So you're probably thinking, well, could I just put pi n? Yes, totally. 0 plus pi n is pi n. But, I could have said pi plus pi n. It would still work. Our range, again, is infinity to infinity. If amplitude is half of the range, then we can't have that in this case. And again, for the period, so a period is a full cycle. I'll use my highlighter once again. Here is a full cycle. So what's the period? It's from 0 to pi. So pi. Now, one thing I do want to point out, when we were graphing sine and cosine graphs, I said that you needed to have at least 5 points to graph a period. So for this, it's the same thing when we're graphing cotangent or tangent. You are still graphing 5 points, although 2 of them are asymptotes. So you'll have 1, 2, 3 points, and then the asymptotes need to be graphed correctly. Okay, so let's talk about this in a general sense, because obviously it's not always going to be that simple. So here's a generic function for us. Y equals a times tangent of bx minus c plus d. And then very similar for cotangent. Okay. So one thing it says here, it says first, when we graph this, we're going to find our starting x value. Now notice that I didn't refer to this as being our horizontal shift, because when we graphed sine and cosine, we did that, but this time it's really our starting x value. So to do that, we're going to set bx minus c equals negative pi over 2. This should give us our first asymptote, which is one of the 5 things that you guys need to graph. Okay? And you're going to solve for x. Now, how's this different than before? Well, remember, for sine and cosine, we were actually setting that equal to 0. Also, one thing I want to keep in mind is this is for tangent only. So there's something different for cotangent. For cotangent, we're going to set bx minus c equal to 0, just like before. And we can call this a horizontal shift for cotangent. Okay, second thing we want to do is find the period and intervals, right? We want to figure out how can I set those intervals. So it is the same for tangent and cotangent this time. For the period, we're going to do pi divided by b. If you're wondering where b is, look at here. Nice. And then for the intervals, it's actually the same as before. It is the period, but divided into 4 intervals. And then the last thing is to draw the new horizontal axis, D, and plot points. One thing that I do want to point out is, remember in these graphs, it was like up to 1, down to 1, and then continued on. So these points right here are affected by the the A value, which before that had to affect our amplitude. And we don't have an amplitude this time, but it does stretch those points or shrink.